Hi fellas, this is Chemaddicts again to the solution. Welcome back to another video tutorial. Feeling cold. It's raining outside and feeling cold. Okay. So cold. So now fellas, now we're gonna solve question 21B of this question paper. Okay, so this is question number 21B. You all know fellas that this is question number 21B of question paper Jan 2017. We were solving question paper Jan 2017 and the question number is 21B. Okay, so at first before solving this question, let us at first read the question. Okay, Sudan 4 is another azodite. The first step of a suggested synthesis of Sudan 4 involved the preparation of methylbenzene from benzene. Okay, give the reagent and conditions to prepare methylbenzene from benzene. Okay, so fellas, since this involved the preparation of methylbenzene from benzene, so let us at first know how can we prepare methylbenzene from benzene. Okay, so in order to prepare methylbenzene from benzene, we need to carry out alkylation of benzene, if you have remembered. Okay, alkylation of benzene. Okay, or Friedel Crafts alkylation. Friedel Crafts alkylation. What's the spelling, fellas? Okay, F-R-I-D-A-L, Friedel Crafts alkylation. Okay, so the process that we are going to carry out is alkylation of benzene or Friedel Crafts alkylation. Okay, sorry for my handwriting, fellas. So before answering this question, let's talk a little bit about this thing, alkylation of benzene or Friedel Crafts alkylation. Okay, no fellas, we're gonna talk in details about the Friedel Crafts alkylation or alkylation of benzene. Okay, alkylation of benzene or Friedel Crafts alkylation. Okay, I hope that the spelling is right. Okay, so in here we are talking about preparation of methylbenzene from benzene. Okay, preparation. So fellas, hold on tight. I guess that the video solution of this question would be pretty much longer, since we are talking in details about the preparation of methyl benzene. Okay, I know that fellas, it requires a lot of patience to listen these creepy things from me, but I can't help. Okay, you need to listen in order to revise this whole bunch of things. I know it's pretty hard to listen all these things and this makes you confused. Sorry fellas, sorry for that. Okay, so here we are talking about preparation of methylbenzene from benzene. So this method is called alkylation of benzene or Friedel Crafts alkylation. We already know. Okay, so the reagent that is required for preparing methylbenzene from benzene are, the reagent for this reaction would be basically a chloroalkane. Okay, alkane or chloromethane in this case. Since we are preparing methylbenzene from benzene, so the main reagent for this reaction would be chloromethane. Okay, since we get methyl from methane, so we need to have chloromethane. Okay, in this case. Okay, so here we need a condition for this reaction. The condition for this reaction is using a catalyst. Just using a catalyst is the condition for this reaction, catalyst. So the catalyst for this reaction is anhydrous or dry, you may say, anhydrous aluminium chloride. Okay, aluminium trichloride, dry. This should be dry. Okay, so now the question arises that why this should be anhydrous aluminium chloride or dry. That's because anhydrous aluminium chloride should be used since chloroalkanes can be hydrolyzed by water easily. So before we have came to know that chloroalkanes can be hydrolyzed by water easily. So here since the main objective of this reaction is to prepare methylbenzene from benzene, so we expect that this aluminium chloride reacts with this chloroalkane to form this thing, to form this methylbenzene. Okay, aluminium chloride, we always expect in this reaction we always expect this aluminium chloride react with this one to form methyl electrophile. Okay, so if we use hydrous or hydrated aluminium chloride, okay, not dry, then this chloroalkane would react with water instead of this reagent, this main reagent. Okay, this is the main reagent for the reaction. So we always expect this reagent reacting with this one first, generating an electrophile and a nucleophile as well. Okay, which is required for the mechanism of this reaction. So main reagent. All right. Okay, so anhydrous, let me repeat this once again. Anhydrous aluminium chloride should be used since chloroalkanes can be hydrolyzed by water easily. Okay, so side reaction may occur. This is another reason. Okay, so here the reagent is chloroalkane, chloromethane in this case, and condition for this reaction is using a catalyst anhydrous aluminium chloride, or in other words aluminium chloride should be dry. Okay, that's so far. Then now we are going to discuss about the mechanism and type of reaction for this reaction. Okay, so since we are generating electrophile over here, in later we gonna discuss how to generate an electrophile. Okay, so mechanism and type. For the time being, let us know the mechanism and type of this reaction. Okay, mechanism and type of this reaction is electrophilic substitution. So fellas, before we have discussed that benzene favors addition reaction over substitution, but most of the reaction is addition to retain its delocalization, but what should I say, wait, let me see. Oh, sorry, that's right. Benzene generally favors substitution reactions over addition reactions. Okay, since addition in benzene would cause benzene to lose its delocalization and hence its stability. So benzene generally favors substitution, not addition. So most of the reaction is substitution. If you have noticed, some of the reaction is addition. Okay, just like bromine is reacting with benzene is when benzene is reacting with bromine water, so that would be addition reaction, but in this case substitution would occur. Okay, since the substitution favors benzene to be more stable. Okay, so benzene favors substitution reaction over addition. Okay, all right. Types and mechanism. Electrophilic substitution. Benzene generally favors substitution reactions over addition reactions, since addition in benzene would cause benzene to lose its delocalization and hence its stability. That's the main reason behind this thing. Okay, so now let us discuss about the what mechanism of this reaction. Okay, all right. So the mechanism would be like this. At first, let us write down the chemical equation for this reaction. Chemical reaction, chemical so the chemical equation for this reaction is this. So this is a benzene reacting with a chloroalkane, which is, let us first write down the sample HCl, the reaction scheme for the mechanism. Okay, and this is the benzene ring, benzene nucleus, and here we're gonna have R in the side chain plus HCl. Okay, so this is the main reaction scheme of this reaction. So this is chloroalkane and this is what, alkyl benzene, and plus hydrogen chloride. Okay, all right, so let us review this once again. So benzene, in here we are reacting benzene with chloroalkane. So here benzene is reacting with chloroalkane, giving alkyl benzene plus hydrogen chloride. All right, so now in here we are using chloromethane instead of chloroalkane. So here let us write down this thing over here. So let's write this down once again. I know fellas, this is gonna take a lot of time, plus please take patience to watch this video. Okay, since we are doing the revision thing over here, why can't I even draw properly? That's really bad. Okay, this is the representation of benzene. Really bad handwriting, sorry, really bad drawing. I should say really bad drawing. Okay, this is benzene once again, plus instead of R we gonna write H should be in capital letter, CH3 Cl. So we're gonna react together to give methylbenzene. Here we're gonna have methylbenzene, CH3 plus HCl. Okay, so that's the thing. So here we are having chloromethane instead of chloroalkane. So in here this chloroalkane is chloromethane. Okay, clear? Hope so. So this is methylbenzene. So the main product here we are having is methylbenzene, which is the main motive of this mechanism. Okay, so now let's let's get into the mechanism. This was the chemical equation for this reaction. So now let's talk about the mechanism. Okay, so the mechanism would be like this. So here at first we have to we need to generate an electrophile. Since this is an electrophilic substitution reaction. Okay, this is an electrophilic substitution reaction. Okay, since this is an electrophilic substitution reaction, we need to generate an electrophile. We need to generate an electrophile. Okay, so here is the equation for generating electrophile. Here we gonna have chloromethane CH3Cl. Okay, so here we have these bonds. Carbon chlorine bond is polar. Okay, carbon being more del positive and chlorine being more del negative. Okay, carbon being more electropositive and chlorine being more electronegative. So there would be a transfer of electron from carbon to chlorine, since chlorine is more del negative. So here chlorine gonna have pair of electrons over here. This bonding pair of electron will this bonding electron will go to chlorine over here. And here we also have aluminium chloride as the reagent for this reaction, AlCl3. So since we know okay, so here this electron would get donated to this aluminium, since this aluminium has lack of electrons. Since this aluminium has lack of electrons, so aluminium would receive electron from this chlorine atom. Okay, forming a nucleophile and an electrophile. So forming electrophile as well as nucleophile. Okay, so the electrophile would be this thing, H3C, which is a positive. Okay, since it has lost chlorine. And we gonna have AlCl4 minus as nucleophile. So in here in this reaction we have generated electrophile as well as a nucleophile, which we will need in the mechanism. We need both in this mechanism. First we gonna need an electrophile, which is methyl. So methyl electrophile. Okay, and this is methyl electrophile, this is methyl electrophile, and this is aluminium 4 chloride nucleophile. So this is aluminium 4 chloride nucleophile. Okay, all right, so we have an electrophile and a nucleophile. So we have generated electrophile as well as nucleophile. Now let's get to the mechanism of this reaction. Fellas, have patience. Okay, since we are discussing details, don't complain about why the video solution is so lengthy. Okay, it gonna be lengthy since we are talking in details about the mechanism, so don't mind. Okay, so mechanism at last we have come to the mechanism. Well, we have in here we gonna have a benzene ring, benzene. nearly perfect. This is benzene, and here the electrophile, methyl electrophile, will come close to this benzene ring, and this carbon being positive. So since this carbon has lack of electrons, it gonna pull a pair of electrons from the delocalization, just like what we have learned before. Just like nitration of benzene. Okay, just like nitration of benzene, this is also an electrophile. This methyl electrophile will pull out a pair of electrons from the delocalization. Okay, not from the sigma bonds not from the sigma bond, from the pi bonds. Okay, since the pi bonds are weaker than sigma bond, so this electrophile, this methyl electrophile, will pull a pair of electron from delocalization. Okay, continuous pi bond, you may say. Okay, so forming an intermediate, just like the nitration of benzene. So the mechanism of benzene reaction are similar, all the mechanisms are similar. Okay, so this should be like this, plus. Okay, forming this intermediate. In here this methyl group would get joined over here, forming CH3. Okay, and in here, since we all know that benzene has carbon is to hydrogen ratio 1:1. Okay, so, and the formula is C6H5. So sorry, not C6H5, C6H6, and the formula is C6H6. So in here, this carbon would gonna have a hydrogen attached to this thing. Okay, so since this methyl group is attached to this carbon, okay, so initially this methyl group has bonded to this carbon atom by pulling out the electron from the delocalization. So in the delocalization, there is a scarcity, deficiency, or lack of electrons. Okay, so in the delocalization there is a lack of electrons. So the delocalization always want to be stable by fulfilling the electrons, so it gonna pull the electrons from this hydrogen atom. Okay, so from this carbon hydrogen bond, so this delocalization would gonna pull the electron pair between carbon hydrogen bond. Okay, so making this hydrogen bond more del positive, and the bond pair would get involved to the delocalization, and the bond pair would get involved in the delocalization. Okay, so since this electron gets involved in the delocalization, and in here this becomes highly electropositive, this makes susceptible to nucleophilic attack. So in here we have a nucleophile called aluminium tetrachloride, which is AlCl4-. So just like nitro, this chlorine would gonna have a pair of electrons. Okay, so this pair of electrons would get donated to this hydrogen, del plus hydrogen atom. Okay, since this del plus hydrogen atom has scarcity of electrons, since this electron pair gets involved in the delocalization, so this pair of electrons from the chlorine would get donated to this hydrogen atom. Okay, so forming the methylbenzene CH3, okay, plus this one of the chloride from aluminium chloride would get bonded with this hydrogen atom, forming HCl and aluminium chloride. See, aluminium gets regenerated at the end of this reaction. So in the final stage, we're gonna have methylbenzene, then hydrogen chloride, aluminium chloride, as the final product. Okay, so in here, if you have noticed that aluminium chloride is regenerated, okay, so we can say that aluminium chloride is a catalyst. Aluminium chloride over here is a catalyst, okay, since it is regenerated at the end of the reaction. Okay, so fellas, that's it. That's the whole mechanism behind this reaction. Over here, first of all, we need to generate electrophile and a nucleophile for the mechanism. So here, methyl is the electrophile over here, and aluminium tetrachloride is the nucleophile. Okay, so at first we have generated an electrophile and a nucleophile from the reaction between chloromethane and aluminium chloride, okay, aluminium trichloride. So first we have generated electrophile and nucleophile from this reaction. Then at first electrophile attack this benzene molecule. So this electrophile will pull out a pair of electrons from the benzene molecule, forming an intermediate over here, this intermediate. So in here, in this intermediate, it the delocalization has lack of electrons. Since the delocalization has lack of electrons in this intermediate, the electron pair of carbon hydrogen bond over here, this particular carbon hydrogen bond over here, will lose its bonding electron to the delocalization, okay, making this hydrogen more electropositive, which is susceptible to nucleophilic attack, okay. And sooner the aluminium tetrachloride comes to this del plus more electropositive hydrogen atom and attack this hydrogen atom, and a chloride from this aluminium chloride get bonded with this hydrogen atom to form HCl, okay, and aluminium chloride and methylbenzene. So this is how it works, okay. So now fellas, now let's get back to the question that we were solving. So in here they have asked only about reagent and conditions to prepare methylbenzene, not the mechanism. We have just reviewed the mechanism, okay. Since the total mark for this question is 2, we don't require to write down the mechanism, but still we have revised, okay. We have just revised, it is not required over here. So the reagent, first of all let us talk about the reagent. So in the discussion we have discussed about the reagent that is required over here is, since we need to prepare methylbenzene, so the reagent would be chloromethane, okay. Since we need to require to prepare methylbenzene, so we're gonna need chloromethane as reagent. And what is the condition? Condition is using anhydrous aluminium tetrachloride, AlCl3. Okay, so why anhydrous? Because if we use hydrated aluminum chloride, chloromethane would react with water instead of this aluminum chloride, which is really unexpected. Okay fellas, so condition would be anhydrous aluminum chloride as the catalyst. Okay, let's just read the question once again. Sudan 5, Sudan 4 is another azotide. The first step of our suggested synthesis of Sudan 4 involved the preparation of methylbenzene from benzene. Okay, so we need to prepare methylbenzene from benzene. So for that we need to carry out alkylation of benzene or Friedel Crafts Alkylation. So give the reagent and conditions to prepare methylbenzene from benzene. So we know that we can only prepare methylbenzene from benzene by using alkylation of benzene or Friedel Crafts alkylation. So the condition for this reaction is, condition and reagent for this reaction is the following. Reagent would be chloromethane, since we are preparing methylbenzene, so we're gonna need chloromethane. And condition is using anhydrous aluminum chloride as the catalyst. Okay, so fellas, that was it. So fellas, that's the solution to this question. That's all for today. So fellas, thanks for watching this tutorial. I really do appreciate your effort by watching this video. Even though the video is very lengthy, but you still watch it. I really appreciate your effort. It's really amazing. Okay, so congrats fellas, we have made it till the end. Oh, what a relief. Oh, what a relief. We have made the solution at last for you. Okay, so here you go. Help us improve our lessons by giving your feedback. Okay, so give us your feedback. Okay, by giving a like or dislike, both of them would do. Okay, either turn this like button blue or turn this dislike button blue. Okay, we will appreciate either of them. Okay, at least keep any of this thing blue. That's what is expected. Okay, just keep any of this thing blue, that is expected. Okay, since your feedback is really important for us for keep making videos in the future, since your feedback motivates us, your feedback really motivates us to make videos like this. Okay, video solution like this. So fellas, if you have any question regarding the topic, or if you have any confusion regarding the topic or the solution, please let me know in the comment below. Okay, do comment below. So fellas, if you find this solution helpful, here are the similar solutions like this one over here. You may check the similar solution of this question paper of here by clicking here. So by clicking here, you will find the previous solution of this question paper that you have missed. Okay, so I'll put the link over here. Click over here. So fellas, if you are already our fellas, we really appreciate that you are already our fellas, and we really enjoying the fact that we have reached 100 plus fellas, and we really amazed. Okay, So if you are not, please click here to stay updated. Okay, we want to make our fellows team bigger community in this channel. We want to make a bigger community. Okay, our aim is to make bigger community.